All right. All right. 3A.2 part B, sine, cosine, and tangent, triangles, and trigonometry. So you remember how you had to get ready for this lesson by reviewing your special right triangles? If you did your savas like you were supposed to? Yeah. Yeah. So this is where that knowledge had to be dug out to be prepared for, right? So here it says, by picking a point X and Y on the terminal side of an angle in quadrant 1 in X and Y coordinate system and drawing perpendicular, you can establish basically your right triangle definitions, which you all know, correct? No one's like, I've never seen these before. Sokotoa, some old hippie caught another hippie tripping on acid. What? Some old hippie caught another hippie tripping on acid. That's what my teacher taught it to. That's what my teacher taught it to me as.
It's like sort of for Sokotoa, but it's like for
yeah. Anyways, but we all understand this, right? No one's like, I've never seen this before. Okay. All right. Cool. Now we're going to put it in terms of X's and Y's. X's, Y's, and R's. Okay. So that's because we're now on a coordinate plane, which means that there are coordinates now involved. Does that make sense? All right. Everything is focusing on this angle, theta. Across from theta, this is going to be your Y. Your vertical is your Y. Agreed? The horizontal is your X. So when you're establishing the relationship here, sine theta is the opposite over your hypotenuse, and your hypotenuse is your R, your radius. So opposite leg is going to be what value? Y. Opposite of the angle is going to be Y. Your hypotenuse is your R. So we're taking it out of the triangle form and putting it onto the coordinate plane. Do we see how these two are being related? Are you with me? All right. Cosine theta is adjacent leg over hypotenuse. My adjacent leg is my X, and my hypotenuse is my R. Yeah? Okay. Next, tan theta. Your tan is going to be Y over X. So what this tells me is that if I'm given an ordered pair within a circle, a unit circle, I can establish its sine, cosine, and tangent. Does that make sense? Okay. There is a relationship between your X, Y, and your R. Can someone tell me what that relationship is called? Oh, good job. Pythagorean theorem. It's our Pythagorean theorem, which is normally a squared plus b squared equals c squared. But in terms of this, it is x squared plus y squared equals r squared. Because our legs are x and y, and our hypotenuse is r. So do you see how your prior knowledge is being transitioned just a little bit? Still with me? Yes. All right, let's keep going. All right, so making sure that you understand that, all we're going to do is just write it in this pretty little chart, okay? So we're taking what we talked about on the other page and relating it here. Got it? So it's saying in terms of this graph, given a unit circle, your radius is going to equal what? 1. So your R for the unit circle equals 1. Agreed? It's everything else is still X and Y, but our R is 1. So for sine, if you're looking here, your sine is your opposite leg. Exactly. So your sine is going to be your Y over your R, which in this case is Y over 1. So sine theta is just going to be your Y value. So on the unit circle, whatever your Y is your sine. Okay. Your cosine theta is adjacent leg over hypotenuse. And we said that's our X over our R, and our R is 1. So therefore, whatever the X is, that is your cosine. As long as it's on a circle, on a coordinate plane. Your tan theta is simply your y over your x, and you have to find them. A y over x. Okay, so this is useful when we're building our unit circle. What does it say you're gonna have to do with the unit circle? You have to. You will need your unit circle for pre-cal, calculus, and physics. If you take it in college, you shall need it. All right. I was gonna have you fill in your rules for your 30, 60, 90, making sure you remember them. Hope you do. No, we don't remember them. Huh? Oh, but you do remember them. Not this one. It will be them. All right. So if you have a 30, 60, 90 triangle, then and it says that the hypotenuse is 1, that means that this is 1. These are the ratios that you follow for your 30, 60, 90 triangle. The angle that is across from the side that's across from 30 degrees is going to be x. The side that's across from 60 degrees is going to be x square root of 3. And the angle, the side, your hypotenuse, that's across from 90, that's going to be your 2x. So for this, because our hypotenuse is 1, that means that we know that 1 equals 2x. So therefore, x has to equal 1/2. So since x equals 1/2, across from our 30 is going to be 1/2. Across from our 20, no, I said our 20, I'm sorry, across from our 60 is going to be 1/2 times the square root of 3, which is going to be the square root of 3 over 2. All right, so we're going to do now 45, 45, 90. Again, respectively, we have 45 is x. 90 is going to be x square root of 2. And it says we're going to let our hypotenuse, sorry, I didn't mean to cross it out. Our hypotenuse is 1. So for this one, we know that x square root of 2 equals 1. So therefore, x would equal 1 over the square root of 2. Okay, this is not proper math for there to be a square root in the denominator. So we do what's called ratifying. So we would ratify our denominator. And we get square root of 2 over 2. So now we know the value of our x. So across from each 45, its value is square root of 2 over 2, square root of 2 over 2. This is useful because when you are in a unit circle, at these values, you can identify what's the sine, cosine, and tangent by using your sine, cosine, and tangent ratios of opposite over hypotenuse. Sine of 60, right? Cosine of 60, adjacent over hypotenuse, right? So you can use these values to find your sine, cosine, and tangent of your 30, 60, 90, well, not 90, well, technically 90, of your 30, 60 triangles and your 45s. All right, so for example, here we have find the values for the sine, cosine, and tangent of the angle 30, theta equals 30 degrees given the coordinates on the unit circle, okay? So we know that this is 30 degrees. For 30 degrees, we know that it's cosine because we've already established that cosine is your x, right? And we established that sine is your y. And always remember it's alphabetical order, C before S, X before Y. So that's where these are coming from. So the cosine of 30 is the square root of 3 over 2. The sine of 30 is 1/2. And you can go back and see here that that is true. If I'm at 30, the cosine is my adjacent over my hypotenuse. And that's square root of 3 over 2 divided by 1, which is still square root of 3 over 2. If you go here, the sine of 30 is opposite over a hypotenuse, which is 1/2 divided by 1, which is still 1/2, which is why the ordered pair is square root of 3 over 2, comma 1/2. So we're going to write it out. So the cosine of 30 degrees equals square root of 3 over 2. the sine of 30 degrees equals 1/2. Now, to find the tangent of 30 degrees, that's where it's going to require to do a little bit of math. So the tangent of 30 degrees, it comes from, we talked about that ratio being our y over our x, or if you go back to the triangle, for 30, our opposite over our adjacent, right? So that gives us 1/2 divided by the square root of 3 over 2. If we remember correctly, when we are dividing fractions, that means we're multiplying by their reciprocal. So multiplying by the reciprocal means that I'm going to keep my numerator, multiply, and I'm going to flip my denominator. Okay. Cleaning this up, my 2's are going to cancel out, and I'm left with 1 over the square root of 3. Again, we're going to write it in proper math form, which means we have to ratify our denominator. So multiplying the numerator and denominator by the radical in the denominator, that's going to give us a radical times itself, sets it free. So we get square root of 3 over 3 is the tan of 30 degrees. Okay. Once you've done this one time, this is going to always be true. The tan of 30 degrees equals square root of 3 over 3. Okay. Remember how we talked about reference angles? This is going to become very important with reference angles. So why it's important for us to be able to find and calculate our reference angles. All right. Now let's look here. We have theta equals to 45 degrees. So our theta is 45 degrees. So if our theta is 45 degrees, what does that look like? Remember, x is our cosine, y is our sine. So this is the cosine of 45. This is the sine of 45. We know that because we go back here. We can identify opposite over hypotenuse, adjacent over hypotenuse, right? So now we can establish our cosine of 45 degrees equals square root of 2 over 2. Our sine of 45 degrees equals square root of 2 over 2. Our tan of 45 degrees equals, well, we have our y divided by our x, which is going to be square root of 2 over 2 divided by the square root of 2 over 2. And anything divided by itself is 1. So the tan of 45 degrees equals 1. And this will be true for all angles of 45 degrees or with a reference angle of 45 degrees. And we'll talk about a little bit more how to apply that. All right, so following what we just did, I want you to keep in mind, if we let theta equal 60 degrees, what does that look like for the sine, cosine, and tangent of 60 degrees? So you're going to pause and do sine of 60 degrees, cosine of 60 degrees, and tan of 60 degrees. All right, thank you.